Hey everybody, today we're going to learn about section 3.3, which are all about the laws of logarithms. So in the past few sections you've learned about what logarithms are and how to simplify very basic logarithm expressions, but now we're going to figure out what kind of cool things can logs do. So in this section we're going to be doing a lot of really interesting simplifying and condensing and expanding of logs, but in terms of actual real world applications and cool stuff like that, not really here. These are just mostly puzzles and games. So in order to understand these laws, it might be helpful to go back and talk about exponents and how they play. Do you remember when you multiply two terms with the same base in them, what do you do to your powers? If you remember, when you have the same base, you keep the base and you add your powers. How about if you were doing division? If I'm dividing, but I've got the same base, what do I do with my powers? And if you remember, you keep the same base, but you subtract. So the idea of in exponent land, when you have multiplication, it turns into addition. And when you have division, it somehow turns into subtraction. And because exponential and logs are pretty much distant cousins of each other, they're very, very similar, whatever happens in one with exponential is also going to happen in log land as well. So to help you understand the log laws today, if you can remember these exponential logs over here, these exponential laws, you should be just fine. Here we go. There's four of them, and the first three are the most important, but the last one is important too. So these are what logs can do, what we call the log laws. If I have one log of a product, one log of multiplication, that splits into two logs being added. And you take each one apart. Log of one term plus log of the other term. So one log splits into two logs. Multiplication turns into addition. Okay, the second one says, if I have one log of division, that's going to split into two logs of subtraction. And you keep the terms again that you see, and you break them apart. One log splits into two logs being subtracted. The other one says, if you have a log, and inside your log you have an exponent, you can take that exponent and toss it into the front of the logarithm, like this. And that works too. For any exponent, that works. If there's ever an exponent inside of a logarithm, you can throw it in the front of the log. And the last one just says, if you have two logs that are equal to each other, and the logs are equal, and the bases are equal, and these are equal, what do you know about m and n, therefore? If the whole left side and the whole right side are equal, that's only going to happen if both m and n are equal. Okay, so in terms of importance, number 1 and 2 are very, very important. 2 stars for each. Number 3 is also very important, 1 star. And 4 is pretty good too, but I'm going to just draw a smaller star. We don't see this one used as much in pre-calc, but when it pops up, it's like, oh yeah, that's right, that makes sense. That was one of the log laws. Okay, now we can play. So we're going to either be breaking apart logarithms into separate ones using the log laws, or going backwards and condensing a whole bunch of logs into one. So first, why don't we try the first way? If I give you one logarithm, can you split it up into a whole bunch of separate logs? So see if you can find things inside your logarithm like products or quotient division or exponents. And here I do see two things. I see a product, I see multiplication, and I do see an exponent. And I'm really tempted to take that power and throw it in the front, like log law number 3. But a little hint over here. We can only use log number 3 if that power is on everything that's inside the log. Meaning, if it looked something like this, the whole thing is to the 2 power. Then I can toss the 2 and put it in front. But notice here that the 2 is only on the n. So I can't toss it in the front yet. But I will, but not yet. So the most outside thing happening, the first important thing is the product, is m times the n squared. So why don't we deal with that? Remember, log law number 1 says one log of a product is going to split into two logs being added. So log of one friend plus log of the other friend. And the two friends being multiplied are m and n squared. Okay, so I took the product of one log and I split into 2 logs being added. And I'm almost done, but now can you see that I do have the exponent here, and it is on the entire n term inside the log, so now I can toss that guy in the front. So final answer for number 1 will be log of m plus 2 times the log of n. And that is completely done. Number 1. So we took one log and we split it into separate logs using the log laws. Okay, if you want to try number 2 on your own, this is one log of a lot of stuff here. But notice that you have this big square root on the outside, which is very scary looking. But remember, don't let that faze you. When you see radicals, you should be thinking more of the exponents. And here's what I mean. When you have the square root of something, that's the same thing as raising it to the what power? Do you remember? It's to the 1 over 2. So if that helps you start, because now I see lots of exponents, I'm going to think about where am I going to put those, and I see division. So I think what's going to happen to that too. All right, let's give it a try. Well, first thing I do is, the most outside thing to deal with is the exponent. So I'm going to toss that in the front, and I should get 1/2 times the log of m3 over n. All right, so far so good. And the next outside thing that's happening is the division here. So we know from log law number 2, 1 log of division splits into 2 logs being subtracted. But I have that 1/2 in the front, and I know this log inside the parentheses is going to split. So I really need to keep track of my 1/2. So I'll keep the 1/2 on the outside. But inside, my single log is going to split into 2 logs being subtracted. So log of the top friend minus log of the bottom friend. And then the n, I think, is okay, but the m has the cubed on it, so I can move that in the front as well. Okay, again, the 1/2 is staying on the outside, and I have 3 log m minus just a single log n. And as the final answer, that's pretty good. If we want to be a little bit more clear and get rid of the parentheses, we could distribute the 1/2 inside and get 1/2 times 3 is just 3/2 log of m minus 1/2 log of n. That's also a really good answer, and both are fine. And that's the answer for number 2. So again, the first thing we did is we took that square root and we wrote it as an exponent over here. And then any exponents we can throw in the front in order. And we saw division splits. But always make sure you split your log into separate logs using the log laws. Okay, that's if you start with 1 and you split into several. The other way is going backwards. If you give you several, can you use the log laws in reverse? So instructions here are really important because first of all, I say simplify into just one single log or possibly to a single number. So once you get down to a single log here, you might be able to go further and reduce it all the way to a single number, which would be kind of cool. Let's see. Number 3 here. I see log 50 plus log 2. So look and see what operation we have. We have 2 logs, and they're being added. So this is the reverse of the first log law. 2 logs being added came from 1 log of multiplication. That's why they're split into 2 being added. So I'm going to smush these together. 2 logs smush into 1 log of multiplication. And notice we multiply the things inside the logs. We don't multiply 2 logs. We multiply the terms inside. We can always double check. Look at this answer I wrote. And can you see how using the log law I can go directly from there to there? 1 log splits back into 2 logs. Okay, but we're not done. Let's keep going. 50 times 2. And we're still actually not done. This looks really good. But remember, what's my base here? Because it's empty. It's 10. And I can actually simplify this. What is log base 10 of 100? What do I raise 10 to get 100? And my final answer would be 2. The answer for number 3 reduces all the way down to the number 2. And that's your answer. Okay, why don't you try number 4? And I'll open up number 5 as well, in case you want to work ahead. And give them a try. Go ahead and pause the video, try these 3, and we'll meet back up here in a sec. All right, for number 4, I see 2 logs being subtracted. So the first thing I think about doing is I want to smush these together into 1 log of division. But I can't do it yet. There's something in the way that I didn't have in number 3. and that is this front coefficient 3. I have to change that guy first before I smush them together. Well, he's in the front because where was he before? This is the reverse of log law 3. A number is in the front because he was originally here as an exponent. Remember, if you see an exponent inside the log, you can throw him in the front of the logarithm. So now I'm going to go backwards and put him back where he was on the exponent. So I'm going to rewrite this as, let me separate this here. This becomes log of 45 minus, the 3 goes on to the inner 3 as an exponent. That's log 3 cubed. Great, let's keep going. So I can still change this into division if I want, but I really want to just simplify the 3 cubed, which I think I know is 27, right? So come on down here. How about log 45 minus log of 3 cubed, which is, okay, now the fronts of the logs are clear, so now I can smush these together into one single log. 2 logs subtracted smush into one single log, and I divide just what's inside the logs. I'm not dividing the logs, I'm dividing what's inside the log. That's good. I can probably simplify that fraction a little bit because I know 9 goes into both pieces. So I can divide top and bottom by 9. And let's see, this is a base of 10, so I don't think there's anything more I can do with this one. That's the end for number 4. Okay, so 2 logs subtracted smushed into one of division, but first we dealt with this exponent and moved him out of the way. I think I'm going to do the same thing with number 5 and 6 too. I see on number 5, 2 logs added, so I'm going to smush them into one, but not yet, not yet, not yet. Let's move those exponents. Sorry, I said exponents. There's your clue. Let's move those coefficients back where they used to be as exponents. So this would be log of 16 to the 1/2 power. Think about what that means in a second. Plus log of 5 to the 2nd power. Okay, let's actually simplify what that means. Log of 16 to the 1/2, that's log of the square root of 16, right? 1/2 power is the square root, plus log of 5 squared is. All right, so those coefficients in the front are out of the way, we're clear. We can smush these together into one log of multiplication. And remember, we only multiply what's inside the log, not the 2 logs together. And I can keep going. And just like in number 3, this is base 10. So my final answer for number 5, again, is 2. All right, number 3 is done. Number 4 and number 5. To number 6, we need to erase a little bit of space here. So I'm going to erase my work here. Okay. Number 6 is a little bit tricky, folks. And the reason why it is because there's more than 2 terms. But that's okay. Let's just work our way left to right, 2 at a time. Okay, now I see 2 logs being subtracted, so I'm thinking about smushing them into division. But let's see, is there anything in the front that I need to move back into exponents? And no, everything's okay. We're good. So we can go right into our smushing mode. This turns into 1 log of, let's divide what's inside our logs. And the log 5 is just still there hanging out. All right, 3 over 6 is the same thing as 1/2. And we can smush them together. I see now, again, left to right, 2 logs being subtracted, so it turns into 1 log of division. That's 1/2 divided by 5. All right, it's just a little bit of algebra. Remember, dividing fractions is the same thing as multiplying by the recip. So I'll do 1/2 times, not 5 over 1, but 1 over 5. Come on up over here. That's log of 1 over 10. Ooh, I can go further on this one, right? Because this is base 10. What is log base 10 of 1 over 10? What do I raise 10 to get 1 over 10? And my answer is -1. So the answer for 6 is -1. So there you go. That's how you see all 4 of the new log laws in action. Actually, really just the first 3. We haven't seen the 4th one really yet, but we will later. But there's one more extra sort of bonus law that I want to show you that's really neat too. This one just kind of makes sense. Let me show you. First of all, look over here at this example. If I said, what is this equal to? Oh, that's so complicated looking. So don't look at that yet. Let's just look at the exponent. Can you just simplify this? What is log base 2 of 8? What do you raise 2 to get 8? And that would be cubed, 2 to the 3. So really, let me change this into a 3. The 2 is already there, so let's keep him there. and bring the 3 back. 2 cubed. Oh, and 2 cubed is 8. Nice. So now if we go back to the original, and I say, okay, folks, what is 2 to the log base 2 of 8? Can you see a very easy path to just get to the answer like that? It's almost like because the base is 2 and the log has a base of 2, we're sort of doing inverses of each other, right? Remember, logarithm and exponential are opposites of each other. So we're sort of undoing each other. Everything cancels beautifully and just left with whatever was inside the log up there. And that is true. So this log law up here is like a bonus one, log law number 5. If you have a base and you're exponentially raising it to a log with the same base, those are opposites of each other. They cancel each other out, and you're just left with x. You're just left with whatever was inside of your logarithm. Okay? So let's play. Number 1 down here. When you see something like this, you see an exponential with a log, and it just looks complicated. So you just think right away, oh, that's the bonus log law. Now first, before you cancel anything, just say, all right, good, it's just 3. Let's just make sure everything's okay. First of all, do the bases match? This is a base of 10. The log here is empty, so that is a base of 10, so that's good. Everything looks clear. There's nothing sitting in front of my log there. I think we're good. All right, the 10 and the log base 10 cancel, and your answer would just be 3. Good. That's pretty easy. So number 2, why is 2 not easy? I'm really tempted to say, hey, folks, look at that. The 3 and the log base 3 cancel. My answer is just 6. Boo. That's actually not true. There's something in the way here. Can you see what it is? What's different here that we didn't have before? And it's this friend right here, the 2. So just focus your eyes on just this for just a minute. And let's see if we can simplify him before we cancel. There's a 2 in the front. Remember our log law in reverse? Where can we put the 2? Right back as an exponent, right? So this becomes 3 to the just log base 3 of now 6 raised to the 2 power. Very good. Which, again, if we want to simplify 6 squared, that's just 36. Good. Okay, now the front of the log is clear. We're good. Let's check. The base is 3. It's being raised to a log of 3. That's opposite. And we're just left with 36 is the answer for number 2. And there's our bonus log law, folks. That brings us to the end of section 3.3, where you learned our brand new log laws, which are very important, very useful just in terms of simplifying and playing with expressions. In terms of real life examples, not so much. It's just more puzzles, plus our bonus log law that we did here. And that's section 3.3. Good job, folks. See you next time.